Welcome to the DIY Honda Garage channel. The Diagnostic Trouble Code, DTC P0101, indicates that there is a range or performance problem with the mass airflow MAF sensor in Honda Accord models from 2012 to 2017, specifically those equipped with engine types J35Y1 and J35Y2. The MAF sensor plays a crucial role in measuring the amount of air entering the engine, which the Powertrain Control Module, PCM, uses to control fuel injection. If the PCM detects a significant difference between the actual airflow measured by the MAF sensor and the presumed airflow, calculated from readings of the manifold absolute pressure, MAP, sensor, it triggers this error code. The MAF sensor is typically located in the intake air duct just before the throttle body, ensuring accurate measurement of the incoming air. The PCM monitors these values during normal engine operation, and any discrepancies can lead to engine performance issues, including decreased fuel efficiency and increased emissions. In summary, understanding the role of the mass airflow and manifold absolute pressure sensors is vital in efficiently diagnosing and addressing DTC P0101. Recognizing the various symptoms associated with this diagnostic trouble code, such as poor engine performance and increased fuel consumption, can guide technicians in isolating the issue. Furthermore, being aware of the potential causes, from damaged intake ducts to misconfigured hoses, is essential in targeting the repair effectively. Following the outlined troubleshooting steps accurately can greatly enhance the chances of resolving the issue on the first attempt. Proper preventive maintenance practices also play a crucial role in ensuring that these components function correctly, safeguarding against future problems and optimizing overall vehicle performance. The MAF sensor is responsible for measuring the volume and density of the air entering the engine, a vital task for the proper functioning of the engine's air-fuel mixture. Its readings directly influence the operation of the PCM, which controls fuel injection accordingly. The MAP sensor complements this by measuring the pressure within the intake manifold, helping the PCM calculate the airflow based on engine revolutions. When the MAF sensor measures a certain amount of airflow, the PCM expects to see a corresponding value derived from the MAP sensor. A malfunction occurs when these values deviate significantly from each other, which prompts the PCM to store DTC P0101. This function of cross-referencing the data between the MAF and MAP sensors helps maintain optimal engine efficiency and performance. The error typically arises in situations where the MAF or MAP sensors are faulty, or if there are air leaks or obstructions in the intake system. Understanding the possible causes of DTC P0101 is crucial for effective troubleshooting. One cause can be a loose or improperly installed intake air duct, which may allow unmeasured air to enter the system, misrepresenting the actual airflow. A damaged air duct could also affect airflow readings, leading the PCM to register a discrepancy. Another common issue is related to the evaporative emission EVAP canister purge hose, which, if misinstalled, can interfere with airflow measurement. Additional potential causes include a damaged intake manifold, which can affect how air enters the engine, as well as a misinstalled MAP sensor that will yield incorrect calculations of airflow based on pressure. Regular checks of these components are vital for maintaining engine performance and preventing the premature triggering of DTCs. Additionally, problems such as a damaged blower motor or improper functioning of the positive crankcase ventilation (PCV) hose can lead to similar issues. When DTC P0101 is triggered, drivers may experience several noticeable symptoms that indicate an underlying issue. Poor engine performance is one of the primary symptoms, often manifesting as sluggish acceleration or hesitation during driving. Additionally, an increase in fuel consumption may occur, causing the vehicle to run less efficiently due to an improper air-fuel mixture. Rough idling can also be observed, with the engine struggling to maintain a steady RPM when stationary, which can be both uncomfortable and concerning. The triggering of the check engine light, MIL, is a common sign, alerting the driver that there's an issue requiring attention. If these symptoms are present, especially in conjunction with the trouble code, further diagnosis is warranted to pinpoint the malfunctioning component or system. The first troubleshooting step for addressing DTC P0101 involves starting the engine and holding it at approximately 3,000 RPM without load. This means that if the vehicle is equipped with an automatic transmission, it should be in the park or neutral position, while a manual transmission should be in neutral. Holding the engine at this RPM is necessary to elevate the engine to an operational state where sensors can accurately begin to monitor conditions. The aim is to run this scenario until the radiator fan activates, indicating the engine has reached a certain temperature and is ready for further testing. This step helps ensure that the engine is in a stable condition to evaluate the performance of the MAF and other related sensors. Following the initial step, the next is to allow the engine to idle for at least 5 seconds. This duration is important as it gives the PCM time to read the data from the MAF sensor and evaluate if it falls within the acceptable range. Stability during this period is vital. Observing how the engine behaves while idling can provide valuable feedback about whether the MAF and MAP sensors are functioning as they should. During this period, it's advisable to check for any pending diagnostic trouble codes, as this may give indicators of other potential issues within the vehicle systems that need to be addressed. By accumulating this data, technicians can gain better insight into what might be malfunctioning. In the third troubleshooting step for DTC P0101, it is crucial to drive the vehicle at a steady speed of at least 40 miles per hour for a minimum of 5 seconds. This step simulates real-world driving conditions that the PCM uses to assess performance under load. While driving, listening for any irregular sounds that could indicate mechanical issues or unusual airflow disturbances can be beneficial. This step allows for observations of how the vehicle and engine are responding under practical operating circumstances, which is essential for the PCM's monitoring process. The results from this step, coupled with the previously gathered data, can confirm whether the MAF and MAP sensors are operating correctly or if further investigation is needed to diagnose the issues. After repairs have been completed to address the cause of DTC P0101, it is critical to conduct a final verification process. This begins by checking the status of the DTC, confirming that the code has been cleared or is no longer present. A test drive should be performed to simulate typical driving conditions, allowing the PCM to re-evaluate sensor performance under load and in different scenarios. It is essential to monitor the vehicle after this test drive to ensure that no codes return, indicating that the initial issue has been effectively resolved. If the DTC does reappear, further diagnostics may be necessary to pinpoint any remaining issues. By thoroughly validating the repair, technicians can confirm that the vehicle's performance and efficiency have been properly restored. To help prevent the recurrence of DTC P0101 and maintain optimal engine performance, implementing a regular preventive maintenance schedule is beneficial. One important step is to routinely inspect the intake air ducts to ensure they are properly attached and free from damage. Damaged or loose ducts can directly affect airflow readings from the MAF sensor. Additionally, the condition of the MAF sensor should be checked periodically, as buildup or contamination can result in inaccurate readings. Replacing the air filter is equally crucial, as a clogged or dirty filter can restrict airflow and lead to problems with engine performance. By focusing on these areas, you can avert potential issues that could trigger the same warning code in the future. Please like and subscribe to the channel. See you next time.